Okay, so we are on question 3 of this exercise. And in this question, we need to compare the cholesterol at the beginning of the study and at the end of the study. What do you conclude? So we have two variables. These variables are, well, the first one is qualitative, and the variable is the time in two categories, pre-study and post-study. And then we have the quantitative variable of cholesterol. These samples are dependent because it's the same individuals measured at 2 points and they can't be separated. So that means if you go to the table, we are in related samples, 2 samples. Now we need to test for normality. Okay, so this is not to see if the cholesterol follows a normal distribution pre-study and post-study. This is actually to see if the mean difference in these two times follows a normal distribution. So that means that we need to first create a new variable. I'm going to delete that because I already have it. So to create a new variable, we need to go to transform, compute variable. I already have it there, but we will do cholesterol 1 minus cholesterol 0. So this is cholesterol at the end of the study minus cholesterol at the beginning of the study. And so we need to change the name. We will name it cholesterol difference. Okay, you can name it whatever you want. Then we need to go to analyze, descriptive, explore, just like we did before. And we're going to use the cholesterol difference variable, plots, normality plots with tests, continue, okay. And it's going to give us all of the statistics like before. So check the mean, 13.4, median, 13.3, skewness, very low, kurtosis, very low. It looks normal. Now we can check the test for normality. Our sample size is big, so we will look at the Kolmogorov-Smirnov. The p-value is 0.2, which is greater than 0.05, so we can say that it does follow a normal distribution. So go back to your table. If we decide that the distribution is normal, we're going to perform the student t-test for dependent samples. So go to Analyze, go to Compare Means, Paired Samples t-test. Now choose for variable 1, cholesterol 1, variable 2, cholesterol 0. Okay. And that gives us our mean cholesterol. So this is the difference. This means that cholesterol got higher at the end of the study compared to at the beginning of the study by 13 points. And we have the 95% confidence interval. Then we have the p-value, so we can say that the differences are statistically significant comparing the beginning of the study to the end of the study in cholesterol, and that mean difference is 13.4. So go back to question number 3, and when we put this in, we decided that it follows a normal distribution, so we will put the mean and the standard deviation. This is a t-test for 2 related samples, the p-value, and the difference. Okay, so if we decided that the differences did not follow normal distribution, then we would need to do a Wilcoxon non-parametric test. So we would go to Analyze, Non-Parametric Tests, Legacy Dialogues, 2 related samples. Then just like before, choose the 2 variables. And we already have checked Wilcoxon, so that's good. Click OK. And it gives us a significant p-value. Then, instead of putting the mean and standard deviation, we would put the median and quartile 1 and quartile 3. And then we would put the difference of medians. Standard deviation of the beginning of the study, so you should use that variable cholesterol 0. And then the mean and standard deviation at the end of the study, use cholesterol 1.